In this lesson, you will learn about how to troubleshoot system issues. After completing this lesson, you will have the practical skills and knowledge required to monitor process activity using real-time debugs, describe how HA virtual MAC addresses are assigned, monitor an HA cluster, check the status of the HA configuration and session synchronization, sniffer the HA heartbeat traffic, troubleshoot some common HA problems, troubleshoot unexpected reboots and frozen units, and use the crash log for diagnostics. In this section, you will learn about general system troubleshooting commands. The get sys status command is usually one of the first debug commands that you use when troubleshooting. The output shows the firmware version, FortiGuard database versions, license status, operation mode, number of VDOMs, and system time. The get system performance status command shows the overall memory and CPU utilization. It also shows session creation rate, number of viruses caught, and number of attacks blocked by the IPS. The last line displays the system uptime. This output gives you a quick view of how much traffic the device is handling. The real-time debug commands generate information in real time about a specific FortiGate process or feature is doing. The debug level is a bit mask value that specifies which types of messages are displayed. The meaning of the debug value depends on each process. However, for all cases, a debug value of 0 means no output. It is disabled. And a debug level of -1 means enabling all possible message types. This slide shows the two commands you use to enable all the IPsec real-time debug output. You can also enable the option to prepend the system time to each debug line. It's important to disable any real-time debug after using it, because they consume FortiGate resources, and some can be CPU intensive. Application layer test commands don't display information in real time, but they do show statistics and configuration information about a feature or process. You can also use some of these commands to restart a process or execute a change in its operation. Some CLI debug commands generate a lot of output. If you know that the information that you need is contained in a specific line of the output, and if you know a key word that you can use to find that line, then you can use the grep utility. This utility displays only the lines that match a text string. For example, in this slide, we used the grep utility to find the IP address 10.10.1.2 in the ARP table. We used the debug command diagnose IP ARP list to get to the ARP table, and then we appended the grep utility to display only the information for one IP address. The result? The output is only one line, containing exactly the information we need instead of a long list of entries. When you display the FortiGate configuration through the CLI, you can use the grep utility with the option -F. It will display only the configuration sections, or tables, where the text string matches at least one value. This is useful when you want to find all the references in the configuration to a specific object. In this slide, we use the -F option to find all the references to the WAN 1 interface. The output shows only the two tables where WAN 1 is referenced. the definition of the interface itself, and a firewall policy where WAN1 is the destination interface. In this section, you will review HA operations and learn about some HA troubleshooting commands. To forward traffic correctly, a FortiGate HA solution uses virtual MAC addresses. When a primary joins an HA cluster, each interface is given a virtual MAC address. The primary informs all secondary units about the assigned virtual MAC addresses. Upon failover, a secondary adopts the same virtual MAC addresses for equivalent interfaces. The HA virtual MAC addresses assigned to each interface are determined by the HA group ID, the virtual cluster ID, and the interface index. So if you have two or more HA clusters in the same broadcast domain and using the same HA group ID, you might get MAC address conflicts. For those cases, it is strongly recommended that you assign different HA group IDs to each cluster. You can use the diagnose, hardware, device info, NIC command, the same command you use to get interface traffic statistics, to display the HA virtual MAC address assigned to your interface. After a failover, the new primary broadcasts gratuitous ARP packets, notifying the network that each virtual MAC address is now reachable through a different switch port. In most networks, that's enough for the switches to update their MAC forwarding tables with the new information. However, some high-end switches might not clear their MAC tables properly after a failover. So they keep sending packets to the former primary even after receiving the gratuitous ARPs. In these cases, you should use the command link failed signal to force the former primary to shut down all its non-heartbeat interfaces for 1 second when the failover happens. This simulates a link failure that clears the related entries from the switch's MAC tables. FortiGate HA uses FGCP, the FortiGate clustering protocol, for HA-related communications. The FGCP travels among the clustered FortiGate units over the links that you have designated as the heartbeats. The FGCP traffic uses a different Ethernet type than the IP protocol. It actually uses 3 different Ethernet types, depending on the operation mode, transparent or NAT route. Let's look at how an HA cluster in active-active mode distributes traffic. First, the client side sends a SYN packet. It's always forwarded to the primary FortiGate using the internal interface's virtual MAC address as the designation. If the primary decides that the session is going to be inspected by a secondary, the primary forwards the SYN packet to the respective secondary. In the example shown in this slide, the designation MAC address is the physical MAC address of the secondary FortiGate. The secondary responds with SYNAC to the client and starts the connection with the server by directly sending a SYN packet. When the server responds to the TCP SYN, the packet is sent to the primary using the external interface's virtual MAC. The primary signals the secondary, and it is the secondary that replies to the server. As you can see, the objective of active-active mode is not to load balance bandwidth. The traffic is always sent to the primary first. The main objective is to share CPU and memory among multiple FortiGates for traffic inspection. Next, the client acknowledges the SYNAC. It's forwarded to the primary using the virtual MAC address as the designation. The primary device forwards the packet to the secondary inspecting that session, using the secondary's physical MAC address. If you connect to a secondary's console port while it is joining an HA cluster, you should see the messages shown in this slide. First, the secondary tries to synchronize the external files. The external files include the FortiGuard databases and digital certificates. After that, the secondary synchronizes the configuration. The last message indicates that the secondary has successfully joined the cluster. If the HA cluster forms successfully, the GUI displays all the FortiGate members with their host names and serial numbers. When troubleshooting a problem in an HA cluster, it is useful to know that you can connect to the CLI of the secondary from the primary CLI using the command execute HA manage with the secondary HA index. To get the list of secondary FortiGates and their HA indexes, use the question mark at the end of that same command. Using the CLI, you can get more information about the status of the HA. For example, the command diagnose sys HA status displays heartbeat traffic statistics, as well as the serial number and HA priority of each FortiGate. This command also shows the heartbeat interface IP address automatically assigned to the primary FortiGate. The get sys HA status command provides much of the same information as the diagnose sys HA status command, plus the following additional output: HA health status, cluster uptime, criteria used to select the master unit, override status, status of the monitored interfaces, and status of the HA ping servers. The HA uptime is one of the variables used to elect the primary unit. Depending on other variables and configuration, the units might compare their system uptimes to elect the primary. If that happens, and if there is one member whose system uptime is 5 minutes more than the system uptimes of all the other units, that member is elected primary. You can use this command to compare the system uptimes of all the units in a cluster. A good indication of the health of an HA cluster is the status of the configuration synchronization. To check that all the secondary configurations are synchronized with the primary configuration, you can execute the command diagnose sys HA checksum show in all the HA units. If a secondary FortiGate displays exactly the same sequence of numbers as the primary, its configuration is synchronized. Also, and as long as there are no configuration changes happening in each of the devices, the debug zone and the checksum zone must display the same sequence of numbers. Later in this lesson, you will learn some tips for troubleshooting when this is not the case. The checksum zone contains the checksum of the configuration that is actually running in the device. The debug zone is where configuration changes are first stored before applying them to the running configuration. So, during the configuration change, you might see that the debug zone checksum differs from the checksum for a short time, while the configuration changes are copied to the running configuration. After that short time, both checksums should match again. Instead of running the diagnose sys HA checksum show command in each of the cluster units, you can run the diagnose sys HA checksum cluster command only on the primary. It shows the checksum for all the cluster members. This command is easier to use. However, if there are communication problems between one of the secondary units and the primary, you might need to use the diagnose sys HA checksum show command instead. HA session synchronization is disabled by default. If you enable it, you can check the primary session table to see which sessions have been synchronized to the secondary units. They are the ones with the synced flag. Additionally, and for the case of all sessions, the HA ID field shows the HA member ID of the unit that is processing the traffic. There are 3 occurrences that can trigger a failover. 1. When the primary stops replying to heartbeats. 2. When the link status of the monitored interface goes down. You can configure an HA cluster to monitor the link status of one or more interfaces. And 3. When a server, identified by its IP address, stops replying to the ping sent by the primary. You can configure an HA cluster to periodically send a ping to one or more servers to test the connectivity between the primary unit and the network services. If a failover happens, the best tool to use to get information about the failover is the FortiGate logs. If the failover happened because the primary unit failed, the secondary unit's logs should show these log entries. If a new primary was elected because one or more monitored interfaces failed, the former primary displays logs similar to the ones shown in this slide. In the example shown here, the primary unit is reporting a problem with the monitored interface port 1. If a device can't join a cluster, follow these steps. 1. Verify the HA settings. 2. Verify the firmware versions and hardware models. 3. Verify the physical layer connections. And 4. Use the HA real-time debug while the unit tries to join the cluster. Run the debug both in the primary and the unit with the problem. If the problem is that the checksums between the debug zone and checksum zones don't match, you can try to fix it by forcing the recalculation. Traffic from session synchronization is bandwidth intensive. If the session creation rate is high, session synchronization traffic can interfere with heartbeat traffic, creating delays in heartbeat replies. There are 2 configuration changes that you can make that might help. 1. Use a different interface from the heartbeat interface for session synchronization. 2. Delay the synchronization of new sessions by 30 seconds, so short-lived sessions are not synchronized. High CPU issues could also create HA heartbeat problems. In those cases, troubleshoot and fix the high CPU problem first, before checking the HA status. In the final section of this module, you will learn how to troubleshoot system crashes. In some FortiGate models, you can configure the device to store all the console logs into the flash memory. This is especially useful when troubleshooting unexpected reboots and units that randomly become unresponsive. Once the logs are stored, they can be displayed from the CLI or downloaded from the GUI for further analysis. This slide shows the commands for enabling, displaying, and clearing the console logs. A crash dump message is usually generated through the console port when the device crashes. Crash dump messages can provide useful information to Fortinet developers. If the problem is a FortiGate that is rebooting unexpectedly, the administrator should check the logs, the console logs, and the crash log. If the FortiGate model doesn't support a console log, keep a laptop connected to the console port, run the commands in this slide, and wait until another crash happens. We say that a FortiGate freezes when it stops handling traffic, and there's no way to connect to it. You can't even access its console port. Only power cycling fixes the issue. For those cases, you could capture any crash dump in the console port. Additionally, and in the case of models with more than one CPU, you can enable the NMI watchdog feature, which automatically crashes the system and forces the crash dump when no new daemons have been scheduled in the last 10 minutes. This is an indication that the unit is not operating normally and might be frozen. Some FortiGate models also have an external NMI button. If the unit is frozen and no crash dump has been generated, you can press the NMI button to force a crash and get a crash dump. Each time an application crashes or closes, an entry is generated in the crash log. When an application crashes, the entry contains the name of the application, the time it crashed, and the termination signal. This slide shows a sample of a crash in the crash log. In this example, the application that failed was the SSL VPND process, which manages SSL VPN connections. The termination signal is 11, which is a segmentation fault. This table contains the most common termination signal numbers. Any administrator can manually kill a process by using the command diagnose sys-kill, followed by the process ID and the termination signal number. The command diagnose sys-top lists the process ID numbers. Manually killing a process is not usually required under normal circumstances. If you have to kill a process, use the termination signal 9. Improperly killing a process can make a FortiGate system unstable. So, how do you know if the crash log is normal or not? In most cases, entries in the crash log are normal. A crash log entry can be considered suspicious if it happens at the same time as a failure in a FortiGate feature or abnormal behavior in the FortiGate. For example, a crash log entry that is generated when the unit unexpectedly reboots might provide information about the cause. A crash in the SSL VPND process, when all SSL VPN users are disconnected, is also relevant. The crash log includes the details about the crash and information that can be used by Fortinet development to determine which code triggered the problem. In this lesson, you learned about the following: general system troubleshooting commands, enabling real-time debugs, HA virtual MAC addresses, traffic flow in HA active-active, monitoring an HA cluster, checking configuration and session synchronization, FGCP and HA log samples, HA troubleshooting tips, crash log, and troubleshooting unexpected reboots and frozen units.